Let's take a look at the concepts of domain and range. Now, domain basically represents all possible x values, while range represents all possible y values. Some people remember this based on alphabetical order because D comes before R and X comes before Y. Those two go together. Domain, X values, range, Y values. All right, let's take a look at this relation. Remember, a relation is just a set of ordered pairs. We've got 2, 5, 1, 7, and negative 3, 9. Since the domain is all possible x values, all we want to do here is take all of our x values, 2, 1, and negative 3. Now, it doesn't have to be this way, but proper mathematical practice says let's just put these in order. So all these x values, negative 3, 1, and 2, let's go ahead and write those right down here. Negative 3, 1, and 2. Those are just all our x values. All right, next we want to consider all our y values. So our y values are going to be 5, 7, and 9. So let's go ahead and put that as our range. 5, 7, and 9. It's as simple as that. Our domain, the x values, range, y values. Let's take this relation here. Negative 2, 5, negative 2, 7, 3, 5, 3, 7. For our domain, again, let's take a look at the x values. That's going to be negative 2, another negative 2, and 3, and another 3, okay? So we've got the values of negative 2 and 3. Now we don't need to rewrite those twice, so I'm just going to write negative 2 once, and that'll cover both of these negative 2's, and then I'm going to write 3 once, and that's going to cover both of these 3. So I don't have to write each of those values again, even though they repeat. Okay, looking at our range is going to include all the y values. That's going to be 5, I'll just circle those, 5 and 7, 5 again, and 7 again. So it looks like we only have 2 different values, the values of 5 and 7. Keep in mind, you might not always be dealing with the set of ordered pairs specifically, but we can represent those ordered pairs using a table, a graph, or a mapping, so you might have to deal with some of these as well, but the concept is the same. Domain is the x values, range is the y values. Alright, moving on, let's go ahead and write some functions to represent these scenarios. Make sure to define x and f of x values, then determine the domain and range. Alright, here we have Sandra can knit 3 scarves per week. Write an equation that represents the total number of scarves knit at the end of any given week. Alright, first thing I notice is that she can knit 3 scarves per week. This number of scarves she can knit is changing based on the number of weeks. So I'm going to take that and let x equal the number of weeks. So depending on the number of weeks, we'll have to multiply that by 3 because she can make 3 per week. Alright, we want to write an equation that represents the total number of scarves knit at the end of any given week. Okay, so this is our ultimate goal. What is the total number of scarves knit? Let's let our f of x value equal the total number of scarves knit. Alright, now that we've defined our variables x and f of x, let's try to set up an equation or a function to represent this scenario. Well, thinking about this, I know that we have 3 scarves per week, so I know that for every 1 week, I'm going to multiply each week by 3, and then that is going to give me the total number of scarves. So I can set that equal to f of x. So this basically says that f of x, my total number of scarves, is equal to 3 times however many weeks it's been. Perfect. Now that we've got our function, we can find out how many scarves she's knit for any number of weeks. If we wanted to find out after 2 weeks, well, we'd plug 2 in for x. That'd be 3 times 2, 6. If we wanted to find out 10 weeks, we could plug 10 in for x. That would be 3 times 10, or 30. So we can use this to determine lots of things. But we may have some possible restrictions on the domain and range as to what will work with our function. To explore those, let's look at the domain and range. The domain is all possible x values, and x represents the number of weeks. Remember, our problem talks about the end of any given week, so we just want whole weeks. So, well, we can't have negative 5 weeks. That wouldn't make any sense, right? Okay, well, is it possible to have 0 weeks? Yeah, if she's just starting out, so 0 is a possibility. What about half a week? Well, we want at the end of any given week, so half a week wouldn't make sense. So what about 1 week? Yeah, that makes sense. Or 2 weeks, or 3 weeks, or 4 weeks. and we can keep going on, 5, 6, 7. So our domain looks like it's going to be 0 to infinity of all positive integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. All right, let's look at our range. Well, again, could she make -7 scarves? Okay, that doesn't make any sense, right? So any negative values are not included in our range. How about 0? If we have 0 weeks, that means she's made 3 times 0 or 0 scarves. So that makes sense. We can have a y value or an f of x value of 0. Okay, what about 1? If she works 1 week, that would be 3 times 1 or 3 scarves. If she works 2 weeks, that would be 3 times 2 or 6 scarves. And it looks like we're going to be moving in multiples of 3. So we can go 9, 12, and that would continue on increasing by 3 every value, right? And that makes sense because every f of x value has to be a multiple of 3. So here's our domain and range, all possible values that will work with this scenario. Let's try one more. Greg is $20 and gets an allowance of $2 a day. All right, I see right here that depending on how many days there are, he's going to get $2 more. So I'm going to go ahead and let x represent the number of days. All right, write a function to represent the total amount of money Greg has if he does not spend anything. So that's our overall goal. What amount of money does Greg have in total if he saves all his money? So let's let f of x equal the total amount of money. All right, in writing our function, let's think about this. Well, the total amount of money Greg has is going to equal, keep in mind, he already has $20, so we have to count that. So let's say 20 plus, he also gets an additional $2 a day. So let's go ahead and say 2 times however many days it's been, or x. Now we've got our function. So let's take a look at our domain and range. What possible x value, number of days, works with this situation? Well, again, we can't have a negative number of days, so our domain is going to start at 0. We can have 0 days, 1 days, 2, 3, 4, and we'll put these dots because we can keep going on for future days. All right, now looking at our range here. So our possible x values are 0. We can't have a negative amount of money, but since our first value is 0, let's see what happens if we put 0 in for this x. That's going to be 20 plus 2 times 0, or just 20 plus 0, which is $20, which makes sense. If Greg hasn't received any allowance yet, he already has $20. So our first range value is going to be 20. From there, each day Greg receives allowance, he adds $2 more. So at an x value, or the first day, Greg is going to receive $20 plus 2 times 1, or 2, or 22. The next day he'll receive $2 more. That will be 24. The next day 2 more, 26. And that's going to go on and on and on until Greg is a millionaire. All right, so when you're doing these, be very careful in establishing what your x and f of x value is, and then you kind of have to think about the situation to set up your function and establish what your domain and range are.